Hello, everyone. Today we're going to be talking about my personal favorite science topic, which is geology. Anyone who's ever tutored with me knows that this is my favorite, and who knows why, it just is the most interesting to me. So I'm going to get started by sharing my screen with you. Okay, so today we're going to talk about, let me see if I can move this over. Hang on a second. Let me move this over here. Okay, we're going to talk about geology, which is, like I said, my favorite thing to talk about. Geology is basically the theory explaining the structure of the Earth's crust and many associated phenomenon as resulting from the interaction of rigid lithospheric plates, which move slowly under the underlying mantle, which is basically tectonic plates, and we will talk about that. So don't let all that vocabulary fuddle your mind. One thing I love about geology is just I'm fascinated with like earthquakes and volcanoes, and it's the movement of these tectonic plates that causes that kind of phenomena. So it's always been really interesting to me, but we're going to start right from the beginning, which is when the Earth actually formed. Now, before I start with this, I just want to talk a little bit about the British and the mid 1800s, because for whatever reason, there was an intellectual explosion at this time, and the British wanted to know everything about the Earth. And so as we go along, a lot of the discoverers that we're going to talk about are going to be British in origin, and they're going to be presenting their theories and talk about these things that they were so curious about the Earth. And so this is where we get a lot of what we know today, and it's all like really interesting. But let's start from the very beginning. So a star explodes and leaves in its place a nebula, and there's all these elements left in that nebula, and then gravity shrinks or brings it all together, and forms a solar system. And at the center of our solar system is our sun. But when the Earth started to form, all of the heavier elements, due to gravity, go to the center, and then the lighter elements build on top of that. So here we have the Earth. Here we have the core here in the middle, which is mostly made out of iron. So we have the inner core, the outer core, the mantle, and the crust. And of course, most of what we know actually is on the crust. We've actually never obviously penetrated the core of the Earth. And it's kind of interesting to think about, because you probably assume that scientists know everything about the Earth, but in fact, we don't know as much as we probably should. And a lot of what we know is hypothetical. And in some cases, we know more about outer space than we do about our own Earth. So when the Earth formed, this crust, there are two types of crusts. We have the continental crust. Continental crust is basically the land that we live on. It's what comes up above the ocean floor. And then we have oceanic crust. And both of these are important for reasons that we will go into. Now, at the formation of the Earth, nobody really knows what happened, right? So this is all theoretical, but they believe that 3.5 billion years ago, the Earth was just a water world. And so a lot of the scientists now there's a lot of theories about how did land actually develop. And so one of the theories is, of course, through plate tectonics. And as I've said before, plate tectonics, they smash together and they slide past each other, and they do a lot of things, and they are constantly moving the shape of the crust all the time. And so some of the theories suggest that a lot of our land masses began at first by tiny islands that were created through like continuous volcanic action, volcanic action that started on the ocean floor, and just volcano erupted, and finally land appeared up above the water. And first it was tiny islands, and then at one point it was just one giant landmass. And with that said, we're going to take a moment to talk about Alfred Wegener. I can promise you that no matter what version of the OGTs you're going to take, you're going to see something about Alfred Wegener on there, because he is the person that theorized what we call the supercontinent. He proposed this theory in 1912. And a few things brought him to the conclusion that there was a supercontinent. Now, remember, before this, this is like during this time where there's that intellectual explosion. And really, before this, nobody really knew much about our Earth at all. And so things that we know today or think we know today, this was all like brand new, like stuff that no one had ever heard of. So Alfred Wegener was pivotal in this. So he noticed that all the land masses seemed to fit perfectly together. You might have noticed something like this when you were in the second or third grade and you're looking at a map of the world and you're like, that looks like that could have fit together at one time. Most specifically, here at South America and Africa, and this is usually how the OGTs frame the questions, by the way, is they'll talk about the South America and Africa fit, even though it's all the whole entire like land that we know, the world that we know, all fit together at one time, and then they slowly started moving apart. So he noticed that they all seemed to fit together. And also at this time, around the mid to late 1800s, believe it or not, nobody knew what a dinosaur was before that time. And it was around this time that they discovered all of these fossils and started putting together that there were these other like giant creatures and sometimes small creatures that used to live on the planet millions of years ago. And so this is when we started really learning about dinosaurs. But they were finding the fossils of dinosaurs in some pretty strange places, and famously so, and like the OGTs will inevitably bring up, in South America and Africa right here. And there are several dinosaur types or creature animal fossils that we find that are connected right here. There's also plant fossils that seem to cross a broad range. And we've got another like dinosaur fossil here. But there were all types of fossils in locations that should have never fit together, right? If you think about South America today, which is basically like a tropical rainforest, it's very wet, the climate is very, very different than it is here in Africa, which is very arid and dry and desert-like. And the same species should have never belonged together. Could not have survived in that same climate. Not to mention, but these are now like ocean and entire ocean apart. So with that said, there was also a rock fossil that suggested the same geological activity existed. The same geological action was happening at that time. I'm actually going to go back if it lets me. I don't think I can. But I do want to tell you that when Alfred Wegener brought this up, he was laughed at. Like the other scientists were like, all right, sure. Like you can tell us, sure, you've got this pretty compelling fossil record. And sure, yeah, it looks like everything fit together. But guess what? It doesn't, you don't have the first word to tell us how the land masses split apart. You can't even begin. And you know what? They were right. And he really couldn't even begin to tell you how all of those land masses split apart. But we now know, and it was only in I think the 1970s, that we discovered plate tectonics. You probably think plate tectonics have been around forever, and they technically have. But we didn't know about them until the late 1970s, where it was actually proven that these exist. And so plate tectonics are constantly moving the Earth around. And as a matter of fact, beneath your feet right now, they're probably moving. And there's a lot of theory right now that you know, in 2 million years, the Earth is going to look very, very different than it does right now. The Earth is anything but a static place, and it is constantly moving. And one theory, for example, is that San Diego is going to be where San Francisco is in 2 million years, because that particular plate is moving upward or northward. And they also think that Africa, let me pull this up for you, is in the process of forming a new continent. Okay, so I'll show you what I'm talking about here. I'll just pull over this website. Africa is splitting in two to create a new ocean. So Africa is currently right now creating a new continent. You can see it right here. And so it's just pulling apart. So in short, plate tectonics are always reshaping our Earth. This was through the work of Alfred Wegener. And let me stop a moment to tell you, if you haven't done this already, make sure you have a notebook and a pen and you're taking these notes down. This stuff that I'm going over today will for sure be on the OGTs. It always is. So it's really important to know. So make sure you're writing it down. If you need to rewind a little bit to write down a little bit about Alfred Wegener and all that, make sure you do that. It's going to be on there. So I just have some terminology, which again, you'll probably want to write down. Because I've seen some of this vocabulary on the OGT. You need to know the difference between folding and faulting. This is stuff, creations of an earthquake, the aftermath of an earthquake. Folding is exactly what it sounds like. Okay, so rocks bend instead of breaking. So think of I think in the OGTs, they actually use this example where you have a piece of carpet and you push it together and it has like hills. That's folding. It's not breaking apart. It's like literally just folding, like in a fan, right? That's how you need to think of folding. Now, faulting is fractured crust. It's the displacement of the Earth's crust. I always like to think of the San Andreas Fault as an example of that, which is literally a scar on the Earth. It's a huge scar in California, and I think it's really cool. I'm going to bring you over a picture to show you what faulting looks like. This is where these two plate tectonics meet, and it's just these two are sliding across each other, and so this is like this giant scar that forms. And here's some pictures of it. I think it's pretty cool. Anyway. That's faulting. We're going to talk a minute about the law of superposition, because this is also always on the OGT. This is a pretty simple concept. The law of superposition, I'm going to read you there a little more complicated definition, but I'll make it easy for you. States that in an undeformed stratigraphic sequence, younger layers of rocks sit on top of older layers. Let's just pay attention to this part right here. Younger layers of rocks sit on top of older layers. Essentially, you've got your youngest here and your oldest here. So if you were to go into your backyard, take a shovel and dig a hole and dig and dig and dig, the further down you dig, the further back in geological time you're going. It's kind of like a time machine, right? Because you can see the history of the Earth. So if you go in your backyard, you can see all the history of well, not really, but you can see your history of your backyard. You'll find like fossils, and the further down you dig, you can see what happened to that section of the Earth, right? So the oldest is going to be at the bottom. The youngest is going to be at the top. For example, here at this crust, this slice of land, we have the youngest thing that happened here. Looks like this is some kind of seashell. So this was the most evolved living creature that lived here at A, and the oldest is down here at D. I don't have the time continuum for this right here. Usually on the OGTs, you won't know how many years you're looking at, but they'll ask you questions about what's the youngest layer here, and what, or what's the oldest. Make sure you stop and read those questions carefully, because you can read them too fast and think you've got it right, and you've got the exact opposite question right. So make sure you do those carefully. In another video, I am going to talk about some of the tricks that the OGT uses. And this is a great example of one where they'll have the right answer and the exact opposite of the right answer. So that's why you really need to slow down on those questions. Here's another example here. 10 here is the youngest. I don't know what that is. It kind of looks like a potato to me. I don't know. But this is the youngest, the last thing that happened on this section of Earth. And the further down you dig, you can see you're finding some different things. And then the oldest down here, these look like trilobites to me, which are some of the oldest life forms that we know of, the fossil forms. So youngest here, oldest down here. Read those questions carefully. All right, so now the other question I commonly see on the OGTs, I think this is so cool. This is part of the mid-ocean ridge. So did you know that on the Atlantic Ocean, there's a giant mountain range, and it's bigger than any mountain range that we know of on our crustal part of the Earth. It's huge. There's mountains forming under the ocean at any given time. And so why is that important and why should you care? Well, let me show you why. Hawaii is built off of this. So Hawaii is a geologically new land mass. So the entire chain of Hawaiian Islands is made out of volcanoes. So it was literally underwater volcanoes that would explode. The molten rock would cool down, another explosion cool down, another until it came up above the water. So one question that I see on the OGTs is if you have a scientist traveling and she starts to find newer and newer rocks, what is she swimming towards? She's swimming towards the Mid-Atlantic Ridge. That is fresh rock, fresh land. Eventually it'll pepper itself up above the ocean, and there we have new forms. So land is always developing, changing. Sometimes it's sinking, sometimes it's rising. And the thing to remember is that our Earth is a very dynamic place that's constantly changing. And we're going to talk about rocks for 1 minute, because I know you think rocks are super boring, but they're super not. They're actually pretty interesting, and they're kind of boring, but they really tell you a lot about our Earth's history and the way that our Earth is formed. So I think they're interesting. But let's read a little bit about the definitions of each. The OGTs don't normally ask you about the definitions of these, but they will. I've seen questions where what you really need to know is there is a really a prevailing theory that all rocks start out as igneous, which is volcanic rock. And then over time, it metamorphoses into different types of rocks, right? So igneous, think ignite. All right, it forms when hot molten rock crystallizes and solidifies. The melt originates deep within the earth near active plate boundaries or hot spots, then rises towards the surface. That's your brand new island right there. So the theory is that all rock starts out as igneous, and then it changes over time. For example, sedimentary is the accumulation of mineral or organic particles at the Earth's surface, followed by cementation. So that's rocks are being brought together through like water or different types of erosion or different like natural forces that cement these rocks together. So you've picked up a rock before and it looks like a conglomeration of many different rocks. These are that's what they mean by that. Metamorphic started out as some other type of rock, but has been substantially changed from the original igneous. That's important because that might be on the OGT where they talk about rock's origin being igneous, okay? Sedimentary or early metamorphic form. So these are just rocks that have changed from one form to another. That's all we need to know. We don't need to spend a lot of time on rocks. And that's all I've got for geology today. They always do ask questions about geology. So if you need to go over this video, go over it once, twice, however many times. Make sure you take notes. And as always, reach out to me if you have any questions. And I do one-on-one tutoring, so I can help you out with this. But good luck and make sure you make flashcards. That helps a ton. And then organize them by each category. It'll help you compartmentalize your thinking. So when you're going to take the test, you can easily access that material. I will go over that when I talk about study tips. Anyway, have a great day. Thanks.